Hello. Good evening, everyone. I hope you can hear me. Can anybody thumb up if you can hear me? That's great. Amazing. All right. Hello, everyone. This is SAAD. I'm the data scientist lead at Connected KERB. In this session, we will talk about scaling EV infrastructure. And despite of what's happening on the media, I know there's a lot of going on about related to EV and 2030 goals. Here we'll talk about the technical aspect, the data and the digital aspect of scaling EV infrastructure. I will be with you today for the upcoming 30 minutes. My name is Aisha, the data scientist lead at Connected KERB. I will be joined with SUSANNE KNORR. She's sitting there, and she's our head of site intelligence. You can talk about her, about that title and what she's doing, because it's a cool one. Quickly about our company and what we do. So we are an EV company, EV charging company in the UK. We're 5 years old. We deploy, manufacture, and operate charge points on the street for the public. We're one of the fastest growing charge points in the UK. We have 5,000 installed charge points. And from that perspective, we focus usually on what is called long dwell charge points. That means we expect the car to be parked for longer than an hour. And from that perspective, we always try to offer convenience, affordability, and reliability on our network. And when it comes to charge points, you might think about what is happening in reality. So a quick view on what is happening. So there is 1.1 million EV in the UK, 600 of which are battery-based charge points, and the rest are hybrids. And that considered as 3% of the total market share of the EV in the UK. Still minor, but as you can see here on the right graph, the market is growing fastly. And you can see the sales increased 81% year to year from last year. So this is the car industry. But let's think about the EV charging infrastructure, because this is needed for whatever industry we have. And you can see there's an increase of 42% of charge points. We have total about 48,000 charge points in the UK. That sounds like a great number, but yet this is far behind 2030 goals. We need about 300, 400 charge points at least. And given that growth, that would be very minor. If we're keeping that growth, that would be just 0.5% of what we're looking for in 2030. The second problem is the ones that are broken or iced. There is a significant number. We don't have this number confirmed yet, but it's 5.2%, and these data are coming from ZapMap. But yet, this is a significant percentage of what's happening. And maybe when you think about that, that might justify what is coming on the media. On the media, you can see EV is not that reliable, it's not that convenient yet. And you can see majority of people here from Telegraph saying like 84%, they don't want an EV. It is not that yet. And maybe the rest of them are the ones who actually own an EV. So with all of these stats, if you looked into what is the problem, what is happening. So let's think of you as someone who have an EV. So you might find a charge point. It have a green indicator, which is great, but you're trying to connect. You're unable to connect to the charge point. This is one problem. If you manage to connect successfully, you might end up with not being able to charge. And this is the second problem. If you manage to charge, you might charge for a little bit, and again, it stopped. And why this is happening? And if you manage to successfully charge, the charge point at any given time, it might lose connectivity. If it did lose connectivity, then you'll have a problem. Your cable is stuck. You cannot unplug because there is a socket that blocks your cable. And looking into these problems, we try to minimize them into two categories. You can see one problem related to network reliability. The second problem relating to choosing a good site where it does deliver some utilization, and from that perspective, deliver some revenue, and we can deploy more charge points if we got revenue. And today I will talk to now about network reliability. SUSANNE will talk about utilization. And let's look into the first challenge. What is meant by network reliability? The ability to connect and successfully charge at the first attempt. Think about that. So you go there on the charge point, I want to plug there, it is working, and I'm actually charging. This is rare events happen. When we look into our data, this is a dashboard we've created where we're looking into the frequency of charging attempts, and we group them in a way where it tells us how many times a user tried to charge and ended up successfully charging, and the result of that. And when you look into this data, you can see here 11% failed charging session, 85% success from the first attempt, 5% success after multiple times. And these are the users who got impacted by this number. When you look into this little table here, you can see this user had tried 25 times. During that time, that was 11 a.m., something like that. And if you look there, these are the attempts from the first attempt to the very last one, where you can see that user got a little bit of energy. That's about 13 minutes after the first attempt, and got some power and managed to charge. This is an extended session, which means that the full details of it sits on a different session. You can't see it now. But if we looked into that, that's 25 attempts. This is one of the most high numbers of attempts on our network. If we looked into something else here, let's pick this session, for example. 12 times. The first attempt was 12 p.m. and 2 minutes, and that after 3 minutes, he managed to charge. And you can see 9 kilowatts, 3 pounds, and he managed to charge for 6,000 seconds. You do the numbers. But the question is, why all of these previous sessions have been failed, and this one succeeded? And this is the question that we're trying to answer. Let's look into this session. Let's look into the details of what happened here. And that requires us to look into sensors data and logs data. When we think about our charge points, there's data streams comes every second. And we have 28 data streams. These data streams, some of them comes every second. Some of them are triggered based on certain events. And these sensors data have rich information that can help us understand and detect the problem. But it's a huge amount of data, and we need to work with it. First stream, here we will look into the most important ones for that problem. These are 4 streams. We have charge points and connector status that include error code. We have temperature, meter value, and that comes between 5 seconds brackets up to 60 second brackets. We can configure that the frequency of it. We have charge point change notifications, which indicates if there's any issue on the hardware side, on the software side, or connectivity, if it's available, not available, someone mark it as out of order, anything like that. And then we have those 2 events, which is dedicated to start session and stop session, and have some info comes with it as well. And what we've done, before going into any technical implementation, we start to look and understand this problem. Is it useful for us? Can we do something out of it? And these are the logs data for that previous session. And you can see, during that time, that was 12:17. If you remember, the user started to charge around 12:13 or something like that. So that during his attempts, the charge point went temporary and unavailable. That means it lost connectivity for like 2 minutes or over 2 minutes. And this is coming from charge point notification. If we looked into the messaging, you can see all of these attempts and the response from the charge point, there is no response. This means like, I can't call it. And all of these attempts result to no response from the charge point. And this is how we get the data. So it comes as logs data, and we need to process it, read it, and extract the value out of it. And the outcome of that exercise resulted to, okay, we have done this on almost thousands of sessions, and to be able to see what that could result to. The result was, yeah, we can detect digital and hardware or user error, so we can tell what kind of error is this, and we can see from logs data or sensor data, it has rich information to tell us. And that could result to informing the user in real time what is happening and giving them a recommended action, what to do. The very last recommended action, we want to say, hey, move your car from this charge point and go to a different one. You need to fix that on the charge point. And this outcome articulated the requirements of the system, of what kind of requirements we need for our system. And these are the requirements. When you think about the data streams, we're getting about 3 events per second. The second version of this, we will get 1 event per second, at least 1 event per second per charge point. And think about thousands of charge points. This is the amount of data that we're getting. And then we need to process this data in real time. And in order to do that, you need to have historical access, because if the charge point went offline 3 minutes ago or 20 minutes ago, that might indicate something. And you need to combine all of these data streams together in order to reach out to a conclusion. And from that perspective, you need a highly performance database as well to be able to access this data and read it. And then storing the data critical to store it in a keyed access on timestamp in order to be able to reach out to it. Makes sense. And then ability to perform update and insert functions, and ability to join data from different events and sources. This is very important because in our business, we work with clients, usually city councils or private entities, and we need to link their info into our analytics. At the same time, think about a charging location where it have multiple charge points, and you will want to understand, is that dedicated to a specific charge point or to that location itself or to that user? So these info are very critical to have it in real time, all of them being ingested. The last bit, you want to visualize this using Power BI, and it's very critical for us to use Power BI. We interact with the government, so you might know why it is important. And this is the architecture behind this. So we have data coming from webhooks or APIs or other data sources. We have event stream within Azure services that gets into these data. And happily with Databricks, we do all the ETL processing. And here we can have machine learning models or MLOPS, whatever we want here, to have these real-time analytics runs on Databricks. This is why this is important. And we have Data Lake, which is real-time data storage that connect to Power BI directly to fetch the data. With Delta Lake, we have other data storage that might, for example, in MongoDB, we have aggregated level of data, so that could be combined, reduce the time of analytics. We have MLOPS storage, which have some info about clients, about other things, and all of that being combined and being ready within Delta Lake to be reported directly on Power BI. Within Power BI, you need a premium version in order to have minimized refresh rate. And from that perspective, you will have much more of a real-time analytics. This is the architecture of this. The second part of this is about the charge point itself. For your perspective, the charge points have a component we call controller, and that controller have a firmware, and that firmware produce an error code. The reality is there's no great documentation about these error codes, and what we saw is these error codes might rely to something different, and we need to understand these error codes. And this is what our product team and our Santi, the engineering lead team, worked on to tell the operations team what they need to do as actions in order to solve these errors. And this is another platform where it combined with the previous architecture, where it demonstrates internally for our operation team, do you need to go on site? Is it a software issue? Is it a user error? And that reduces our cost internally as well, because you don't need to send an engineer for every problem. This is a software or a digital problem. And from that perspective, we start to have this is just a demo, real-time Power BI dashboard, where you can see active sessions, you can see the energy flow in our network, across our network. And this is built by Power BI Streams, but you can have it on Power BI Premium, which we don't have yet. We're still under development. And that would combine you all of these real-time analytics happens in real time. And from that perspective, the next step from these things, we need to complete the real-time analytics. We need to have the model that combine all of these data sources and to have it much more robust on what is happening and to inform the user in real time. And we expect that to reduce the fault analysis and the failed sessions on our network. And when you think about this is a purely digital solution, but nobody in the market ever thought about deploying these activities. It requires a bit of engineering, but there's many problems on the EV industry where it could be solved from a digital aspect. If the charge point lost connectivity, if the firmware needs update, if anything happens, it's just a digital aspect. And this is why we need more brains to work and to solve these problems. And with all of the media and all the things happens, just give us the resources to deploy this technology, and it is good for everybody. It could be much more reliable from a grid perspective, from a user perspective, for the environment. And that's it for the network reliability. The second point will be about utilization, but before leaving to Susanne, I would love you to think about the transition to EV. Think about 7 years from now, how this is going to happen. Usually, you can't go and deploy charge points anywhere. You need to be wise about that. And we think about this in a way where there is waves, the first adapters, the second wave of adapters, the third wave of adapters. And these people live and commute to different places. And this is what we're trying on the site selection tool, where we're trying to understand what would be a good location to put a charge point, and how this transition will be. And from that perspective, we deploy charge points in order to get some revenue in order to deploy more. I'll leave you with Susanne now to tell you all about it. And thank you for listening.
Oh yeah.
Go ahead, Susanne.
You get this, and I get this again. Okay, can you hear me? Oh, I can hear myself, amazing. So my name is Susanne, I'm the head of place intelligence at Connected KERB, and I work closely with Ellie, and I'm looking more into choosing the right locations for future charge points. And why is that so important? Because we want to have locations where people like to charge, where there's lots of charging happening, because some or most of our revenue goes through vending energy. So the more energy we sell, the better for us for this particular revenue stream. How do we do this? We measure utilization. Ali talked about this a little bit before. It's for us the main measurement on seeing which sites are successful and which ones are maybe underperforming. Utilization is basically the energy that we went through a charge point in a specific amount of time. So 100% would be perfect. That would be the ideal scenario of someone being plugged in 24 hours a day, but that's obviously not very realistic. So we're happy with something very low at the moment, because adoption is also not there yet. A good site for us is a site that serves the end consumer best. So that means people see the charge point, they like the charge point, it's easy to park there, it might be on your way to work, and it also is integrating in the existing infrastructure and in the planning situation. So we need a specific pavement width, we can't have a tree around, we can't have lots of street furniture around, and we need to place a feeder pillar as well, so that needs to be taken into account. So how do we plan for these things? At the very beginning, it was very much like, okay, well, we think it's a good location, let's place a charge point here. But over time, and as our network grows, and as we have more and more bigger contracts coming in, we needed a little bit of a more sophisticated solution. So we came together as industry experts, as infrastructure planners, and most important, we did data experts, and we built a tool that is map-based, and it contains different models, and these models try to kind of simulate what we see in the network. And as we are at the beginning, we are still learning and learning and learning, and it's ever evolving. So this is a little bit of a sneak peek, and you can have a look into the tool. So you can see there's a specific area we want to look at, and we have different spatial data sets, and we you can see here that it's the flooding area, because you don't want to have a charge point being flooded, because it means it might be broken, so you need to replace it, which is again very expensive, and you need to send someone there. And then you can activate different data layers. It's basically a map, so you can see where people live, what is like the wealth in that area, the affluency, also how many cars do people have per household, and you can in general get a little bit of an idea what the kind of characteristics of an area are. Because we are deploying across the UK, and we have lots of different geographies, and the rural geography is different to one that is in a city. We can also see competitor charge points. As you can see here, we don't want to oversaturate an area, so need to be careful about that. And then also what I'm a little bit proud of is we can also see the power network of low voltage, because we cannot connect to the household electricity, and it's important for us to know on which side of the street the cable lies, because if we have to trench across, it costs more money. So the longer we need to trench, the more expensive. And sometimes we need to connect to a substation, so that also needs to be taken into account when we plan new sites. The coolest thing is that this can auto-generate sites based on the different models that we have in there. So now we'll just rain on some sites here, and then we can actually click on, and we have a planning interface in there. So the infrastructure planners in our house, they can actually put some notes in, or we can have a look around. What is the situation from a Google Maps perspective? And that then feeds into the first stage of planning. So as Ali said before, we are a growing network, and with the growing network, we see more charging behavior, we see more activities in our network. We can also see more behavior of the charge points. So that means we slowly start to understand what the user behavior is and what the charge point behavior is, and we can try to model this to actually have a good idea. So these are two examples of two different sites, and what we can see is that they are very different from each other. So just in-house, for example, we see that users are plugging in their cars way later. So it's in the evening at 6 o'clock, and they charge for longer, so 9 to 12 hours we see a lot. And also completely during the week, so every weekday. When we look at Cambridge Science Park, we see that it's completely different. People plug in the morning, and they won't charge that long, so 3 to 6 hours, 6 to 9 hours, not at all on the weekend, so no one is there on the weekend. So this is a workplace. People go there to work, plug in. This is not a workplace. So when we think about deploying commercially for a workplace or for an office or for a bigger work environment, it's different than on a street. And so what we have is different spatial data sets, and we have 3 big buckets. We work with public data, classically census data, we have lots of industry data, and we also have, most importantly, our self-generated data. And with that, we put different models together, and what we do is experiment. And we also learn how, so we had lots of different experiments, and we also understood that our first theories might have not been the ones that are actually true. So because we have lots of residential chargers, we thought, oh yeah, residential charging. People come home from work, they plug in, leave the car there, and next morning they take the car away. That is not necessarily true. We have lots of people who charge in residential areas over the day, who charge just for a few hours and not the whole night. We also thought, yeah, it's always long dwell. That's not necessarily true. Points of interest do also not necessarily define utilization. And I think one of our most important learnings was that uptime and connectivity have a massive influence on utilization, and that has to do with the mobile reception, because the charge points have a SIM card in there, and this is our connection with the charge point. When they have no connection, then we cannot communicate with the charge point. So charge point cannot start a session or whatever, or a cable might be stuck, and then we need to send someone. It costs a lot of money, right? Because we need to send someone. So yeah, we are still there. We are very good, very, very good in predicting bad sites. We are good in predicting good sites, and as very often, the challenge is the excellent sites, right? Why do some sites outperform any other site? And this is what I'm after in my daily job. What makes it more difficult is that the EV industry is a little bit of a Wild West. We see lots of companies growing, lots of companies going bust. You might have heard yesterday from Rishi Sunak's addressing that the environmental goals might be delayed, so that has an effect for us because the EV adoption and therefore the charging demand will be changing. We also see competitor networks. All the networks are growing, so what does this do with the saturation? Then ideal every day with lots of updated data, the ever-changing traffic regulation orders, ever-changing parking zone restrictions. We have traffic data that is interesting for us because if it's a high street, then people might not want to park there, so it's a different case. And then also, what is a very big topic for us, because it has lots of opportunity, is energy flexibility. Because if there's too much energy produced, like in the storm we had yesterday, lots and lots of energy is on the grid, we can actually take this energy off the grid and offer free charges or very, very cheap charges to our consumers. But therefore, we need to kind of rely that our charge points are working well, right? And we have good uptime, but there's so many things happening, and this is so much in growth, or the whole sector is still kind of finding its place and its processes, that we are in a very, very dynamic environment. I think we have been faster than expected, so we were a little bit afraid that we would take longer, but now we are around for questions, and please connect with us. Thank you very much for coming for our talk, and that was it from us from Connected KERB. Thank you.